Hello everyone. I want to explain uh, linear differential equation with constant coefficients when method of finding particular integral when RHS x equal to e raised to ax into v, where v is a function of x. This formula gives, you see that 1 by fd 1 by fd of 1 by fd means 1 by, this is the symbolic coefficient of y in the given equation. 1 by fd operating on this RHS e raised to ax into v. This gives you see that a method says that shift this e raised to ax from right side of this operator to the left side, provided we have to change, we have to replace here in the function f of d, we have to replace d is replaced by d plus a. D plus a means a, what is a? A means it is the coefficient of x here. In the fd we have to replace d by d plus a, then you have to write v. V is any function of x, any function of x. Okay, this is the formula. If you want proof of this, you can pause this proof and take down this for this proof of this. And this proof is very simple. You can practice this one. Finally you get this one. Then how it is working, how it is using for a particular example, you see that you take particular example. Here 1 by fd is here, suppose you take d square plus 3d plus 2, d square plus 3d plus 2. Suppose our function is x is given, RHS function x is given that e raised to x to sin x, e raised to ax means a is here 2 and v is here sin x. It may be sin x, cos x, or algebraic function x square, whatever it may be. Here I have taken to explain you, I have taken this example how it is working this. Okay, this is 1 by fd. In the place of fd is d square plus 3d plus 2 e raised to ax, in the a is 2 here, and v is sin x. So you see that here I am applying this formula to this one. Here shift this one exponential function from right side of this operator to left side of this operator. Okay, I have shifted this e raised to 2x. Then provide in the same way you can replace here d, every d is replaced by d plus 2 here. D plus 2 means here 2, coefficient of x is 2 here, wherever d put d plus 2 here, d plus 2 whole square plus 3 into d plus 2 plus 2 sin x you write as it is. Okay, this is equal to e raised to 2x into 1 divided by, after simplifying this expanding d plus 2 whole square, all adding you get d square plus 7d plus 12. Then you can operate this one on sin x. Okay, now proceeding as in the previous class we have explained this how to find out the this one by fd of this sin x. You know that sin x plus b cos x plus v. In the previous case number 2 we have explained that one. So d square is replaced by minus 1 square here, coefficient of x, like that. Find out particular integral completely by using that. So one example, you see that everything become clear. If you take one example, solve d square y by dx2 minus 2 into dy by dx plus 5y equal to, RHS function is in this form, e raised to 2x sin x. Same function I have taken this here. This can also be given in this form, in the symbolic form, this one, d square minus 2d plus 5 into bracket y equal to e raised to 2x into sin x. Either it may be given in the this form or this form. If it is not given in this form, you can write here in this form, in the symbolic form you can write. Solution, given equation you write down on this, write down once again, that is okay, this is given in this form. If they directly you write this, d square minus 2d plus 5 into y equal to e raised to 2x into sin x. This you call as equation number 1. First you find out complementary function. To find complementary function, you know that auxiliary equation of this you write. Auxiliary equation is d square minus 2d plus 5 equal to 0. But here d is treated as treated as algebraic quantity, you can read. So, or you can take in the place of d m square minus 2m plus 5 equal to 0, and this is not factorizable. Using formula method you can solve this. D equal to, so here b is minus 2, so minus b minus minus become plus, here 2 plus or minus square root of b square minus 4 ac, you can b square minus 4 ac, 4 b square is 2 square 4 minus 4 ac, a is 1, uh, a is 1, c is 5, so 4 into 5 is minus 20 divided by 2a. 2a means a is 1, 2 into 1, 2. So after simplifying this we get 1 plus or minus 2i. This is d values. One root is 1 plus 2i, another one second root is 1 minus 2i. So using this is one pair complex root, you can write you know that how to write the complementary function. Therefore complementary function equal to e raised to ax. A is here 1, that is real part, b is a beta, imaginary part is 2, so real part is written e raised to ax means e raised to 1x, 1 x, right, into bracket c1 into cos beta x. Beta means here imaginary part, it is 2x plus c2 into sin 2x. This is complementary function. Then you see that using above formula, how to find out the particular integral in this case. Now the particular integral is equal to 1 divided by d square minus 2d plus 5 operating on e raised to 2x into sin x. This is of the type e raised to ax into v is sin x here, e raised to ax, a is to v is sin x. Okay. Procedure according to above, using above procedure, shift this one e raised to exponential function from right side of this operator to left side. Okay, we have shifted e raised to 2x. Procedure says that after shifting, wherever d here, d is replaced by d plus 2. What is the coefficient? D plus coefficient of x, that is d plus 2 whole square minus 2 into, wherever d you write d plus 2 here for this problem, minus 2 into d plus 2 plus 5 into sin x, you write v as it is, v sin x here. First you simplify this denominator by expanding all these, removing all the brackets, equal to e raised to 2x into 1 divided by d square plus 4d plus 4 minus 2d minus 4 plus 5. Simplify this, you get finally equal to e raised to 2x into 1 by d square plus 2d plus 5, and operating on sin x. E raised to 2x as it is you write. Then use the procedure of case number 2 when 1 by fd of operating on sin ax plus b cos ax plus b. So here procedure says that a coefficient of x you see 1, d square is replaced by minus 1 square here. Coefficient of x is 1, d square is replaced by minus 1 square here. So minus 1 square, square is not applicable to minus sign, minus is different, 1 square only, minus 1 square like this, plus 2d plus 5. D you keep as it is, only d square is replaced by, the procedure of this is only d square is replaced by minus 1 square plus 2d plus 5, right as it is. So simplifying this, minus 1 square is minus 1, square is not applicable to minus, minus 1 square is minus 1, 5 minus 1 is 4 you get. So e raised to 2x keep as it is into 1 divided by 2d plus 4 sin x. So but this procedure is only d square is replaced by coefficient of x minus of coefficient of x whole square, but d is there. So bring how to bring d square once again. To bring d square here, take common here 2 outside, e raised to 2x by 2. So here left d plus 2. So to bring this, multiplying in numerator d minus 2 and dividing by d minus 2, multiplying and dividing by d minus 2, and then sin x right as it is. Simplifying we get this is equal to e raised to 2x by 2 into d minus 2 by applying a plus b, a minus b formula, d square minus 4 into sin x. This is equal to, you get e raised to 2x by 2 into bracket d minus 2. This d minus 2 keep as it is. Again you apply 1 by d square minus 4 of this sin x. So here again d square is replaced by minus 1 square, and it is very clear that this is not 0, denominator not 0 after substituting this minus 1 square here. So substitute here minus 1 square minus 4 sin x. Okay, then if simplifying we get minus square is not equal to minus 1 minus 5 into 2, it is minus 10 e raised to 2x by minus 10. So minus of e raised to x by 10 into d minus 2 of sin x. This is again you operate on this. This is differentiation. That is a particular integral equal to minus of e raised to 2x by 10 d of sin x. D of sin x means differentiation of sin x is cos x minus 2 into sin x. This is a particular integral. It is completed. Now add these two sums. A complementary function is okay and particular integral. Now the final general solution you get by using this formula, y is equal to complementary function plus particular integral. Add these two. So you get y is equal to particular complementary function is e raised to x into bracket c1 into cos 2x plus c2 into sin 2x. Close the bracket minus particular integral, this particular integral minus of e raised to 2x divided by 10 into bracket cos x minus 2 sin x. For example, you can try one more example I want to explain you. Example 2, you see that solve d2y by dx2 minus 3 into dy by dx plus 2y equal to e raised to 3x into x square. So here e raised to t, this is of the form e raised to ax into v. Here v is x square, algebraic function here. Here a is 3 here, e raised to x, a is 3. So right given equation is in the symbolic form, d square minus 3d plus 2 into y equal to e raised to, this is a symbolic form you have written. First you find out complementary function. To find that auxiliary equation, right? Auxiliary equation is d square minus symbolic coefficient of I equate to 0. D square minus 3d plus 2 or m square minus 3m plus 2. D is considered as a algebraic quantity here. So factors you get here, d minus 2, d minus 1 equal to 0, d equal to 1 and 2. So real roots and distinct. So in this case, how to write complementary function? You see that c1 into e raised to x plus c2 into e raised to 2x. This is a complementary function. Then therefore, how to find out the particular integral equal to? Particular integral is 1 by fd. Fd means here symbolic coefficient of y, that is d square minus 3d plus 2 operating on this x square into e raised to 3x or e raised to 3x into x square. Here v is. So procedure is shifting exponential function from right side of the operator to left side. Okay, we have shifted e raised to 3x into, at the same time we have to replace d by d plus 3, that is a coefficient of x here. Wherever d, you have to write d plus 3. Okay, d plus 3 whole square minus 3 into d plus 3 plus 2 into x square. Okay, then e raised to 3x, you have to simplify this denominator. 1 by d square plus 6d plus 9 minus 3d plus minus 9 plus 2, then operating on x square. Simplifying, we get e raised to 3x into 1 divided by d square plus 3d plus 2 operating on x square. Then here this procedure is third case, when RHS is x raised to m form, x raised to m, that form says that take out the lowest degree term outside. Okay, here lowest degree term outside, this 2 here, bring outside, take down. So e raised to 3x by 2 it will become e raised to 3x by 2. First you write here one term, first one. Now 1 you get after taking 2 outside. Here you get 1, that you write 1 here plus 1 plus remaining d square plus 3d here not containing 2 divided by 2, that is. So it is right in the form of 1 plus x or 1 minus x in the form. Okay, I have written. Then you have to operate on this x square. This is. Now procedure says that in this case write the denominator and numerator with negative index. This is you keep as it is, e raised to 3x by 2 into square bracket 1 plus d square by 2. Separately you write d square by 2 plus 3d by 2 bracket, close the bracket, then raised to minus 1. Write in numerator with negative index. Okay, x square, then this is equal to e raised to 3x by, this is using binomial expansion. You can expand. Expansion is to be carried out up to the degree d square, term containing d square. So because all the higher derivatives of x square become 0, so expansion is to be carried out up to term containing d square only. So all the higher this is of the expansion using this one plus x raised to, this is of the type this one. So here you get 1 minus x plus x square. 1 minus x means this one. 1 minus x you have to write. Then square of this means higher order degree terms. You get higher order degree terms of this x square becomes 0. So all higher degree terms are neglected. So put dotted dash 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 x square. Only this term is useful here. Okay, then operate on this derivative like this, x square into 1 x square, you write multiply inside x square into, then d square minus d square by 2 plus 3d by 2 of this x square is operating. Remaining terms are neglected. All higher derivatives of x square become 0, so neglected. So this is equal to e raised to 3x by 2. So x square as it is, then d square by 2, 1 by 2 is a constant, d square of x square, it means first derivative is 2x, second derivative is 2, so it will get you get minus 2 by 2, so you get minus 2 by 2 minus 3 by 2 d of x square. D of x square means d of x square means 2x, you get 2x. Okay, I have written 2x. Then finally simplifying all this, we get e raised to 3x by 2 x square minus 3x minus 1. So this is a particular integral. Now therefore the general solution we get y is equal to using CF plus PR, combining these two solutions. So first complementary function is c1 into e raised to x plus c2 into e raised to 2x plus particular integral e raised to 3x by 2 x square minus minus 3x minus 1. This is the final solution of this equation. Okay, in the next video I will explain the remaining few more examples, different examples relating to this topic. Okay, thank you students.